Hello everyone, I am Dr. Regina Anandi, Assistant Professor, Department of Artificial Intelligence and Data Science. Today we are going to learn about the MERN Integration Workflow. MERN stands for MongoDB, Express.js, React and the Node.js. So these four technologies work together to create a powerful full-stack web application. So in this session, we will understand how the front-end, back-end and database communicate with each other in a MERN application. So we will also explore the architecture, workflow and API communication and the real-world case studies. So this slide gives you an overview of the MERN integration workflow. A MERN application combines four technology: MongoDB for storing data, Express.js for backend APIs, React for front-end user interfaces, Node.js as a server runtime. So the integration workflow means connecting all these technologies together smoothly. So the front-end sends the requests, backend processes them, and MongoDB stores or retrieves data. So this architecture is widely used because it is fast, scalable and uses JavaScript throughout the entire applications. Now let's understand each component in the MERN stack. First, MongoDB. MongoDB is a NoSQL database that stores data in a flexible JSON-like documents. It is highly scalable and suitable for modern applications. Second, Express.js. Express is a lightweight backend framework used to create APIs and manage server-side logic. Third, React. React is a front-end JavaScript library used to build dynamic and interactive user interfaces. So finally, Node.js. So Node.js provides a runtime environment that allows JavaScript to run on the server. So together, these technologies create a complete full-stack development environment. Before integration, developers often face communication problems between the front-end, back-end, and databases. So one major issue is data flow gaps. If the front-end and back-end are not properly connected, users may not receive the correct information. Another issue is communication breakdown. APIs may fail if request formats or endpoints are incorrect. There is also integration friction. Managing authentication, routing, asynchronous requests, and database operations can become complex. So the MERN workflow solves these issues by creating a structured communication process between all layers of the application. MERN integration is the process of connecting React, Node.js, Express.js and MongoDB into one unified application. So here's the process, basic process. So React acts as a front-end interface. React sends requests using the APIs. Express and Node.js process those requests. MongoDB stores or it retrieves the required data. The backend then sends responses back to React. This continuous interaction creates a complete web application where users can view, add, update, and delete information in real time. So this diagram here shows the architecture and the data flow in the MERN application. So the process begins with the React frontend. When a user performs an action, React sends an HTTP request to the backend API. The request reaches Express and Node.js. The backend processes the request, applies business logic, and communicates with MongoDB. MongoDB, on the other hand, either stores new data or retrieves existing data. The backend then sends the response back to React, and the React updates the user interface. So this request-response cycle is a foundation of MERN application communication. Now let's look at the workflow step by step. For step 1, user interaction. The user interacts with the React frontend by clicking buttons or submitting a form. Step 2, API request. React sends an API request using a fetch or XSource. Step 3, server processing. Node.js and Express.js receive the request and execute the required logic behind them. Step 4, database operation. MongoDB performs database operations such as inserting, updating, deleting, and retrieving records. Step 5, response rendering. So the backend sends the response to React and the React updates the UI dynamically. So this overall process happens continuously in modern web application. And this slide here shows how the React communicates with the backend using the fetch API. The fetch function sends an HTTP request to the backend endpoint. The backend processes the request and returns data in JSON format. React then stores this data in state variables and displays it on the user interface. The important point here is asynchronous communication. So React does not wait for the server to finish. Instead, it continues executing and updates the UI when the responses arrives. So this makes MERN fast and responsive. Now let's look upon the real-time example of MERN integration. So here we are seeing the online shopping application. So in this system, React provides a shopping interface where user browse products. Express.js handles APIs for product management, authentication and orders. MongoDB on the other hand stores customer details, products and order information. Node.js runs the backend server. When a user places an order, the front end sends the request to the backend. The backend stores the order in the MongoDB and the responses is displayed instantly. So this demonstrates how all MERN technologies work together in a real-time application. So we came to an end. So now we quickly summarizes the key points of today's session. First, MERN is a complete full stack JavaScript framework. Second, React manages the front-end user interface. Third, Express.js and Node.js handle backend process and APIs. Fourth, MongoDB stores application data. And finally, the request response cycle connects all components together. Thank you everyone. I hope this session helped you understand the MERN integration workflow clearly. Thank you.